Welcome back, chickies. If you're watching this, you must be desperate. Or just Miss Jensen. Anyways, today we're doing 4.3 rates of change other than motion. First thing we gotta review is increasing or decreasing. That is the question. We love a little Theodore Hamlet reference. Anyways, so just know, to see if something's increasing or decreasing, you gotta check the derivative, alright? So if the derivative is less than 0, we know it's good. It's not, what's it called? It's less than 0 or negative. We know that the rate of change is going to be decreasing, alright? Your function or whatever is decreasing. Now, if d dx ends up being greater than 0 and positive, then once again, it is increasing. And just for good measure, if d dx equals 0, it is at rest. At rest. At peace, even. Anyway, so yeah, there you go for that. That's how you know if it's increasing or decreasing. And the reason why it's called rate of change other than motion is it's good to note that you can take the rate of change of kind of like anything. And this is kind of a concept you got to understand for what we're going to do in 4.4 with the related rates. Because you can literally have, like let's say the rate of change of someone's like hair. You can literally have d hair dt. All right. And anything you want to take the rate of change of, you can do with any variable. Let's say I want to take the rate of change of, like, for great instance, of, let's say the volume of something. All right. We would have dv dt. Or you want to take the rate of change of water for who cares. We have d water dt. And you can, d over d, or d over dt, and I know over here I showed x, but this t over here is just time. All right, guys, it's something over time, over a change of time. So hair growth over the change of time, water over a change of time, volume over a change of time. Once again, rate of change. This was kind of silly to me, so I would definitely put it on here. If f of x is the bunny population after x years, then what is f prime x? And we know that with this, we would know that, again, f prime x, derivative. So it'd be like f prime x is rate of change. I'm going to write, I'm abbreviating everything. Is rate of change, population of bunny, boop, population at x year, right? But what do you do when it's asking, let's see if I can type this out real quick. What do you do when it switches it up a little bit on you? All right. And instead it asks if f of x is the rate at which a bunny population increases. Then what is f prime x? And this is interesting because, again, we're told, like, find the derivative is the rate. But now it's asking us, what do you do if f of x is already the rate? All right, guys? And basically, and this is actually one of the dumbest things you'll ever see in life, it's going to be f prime x is the rate of the rate. I know, crazy. The rate of the rate at which a bunny population increases in bunnies per year. In bunnies per year. And that crazy. And you basically just kind of keep doing this like f to the double prime x, and you just kind of keep doing that until you die. But you're going to find yourself in a spiral of madness, and you're going to look like this guy over here. So just don't do it. Save yourself some life and time. All right, cool beans. Anyways, so we have an example here. It's actually a bit of a throwback. Take the time and read the problem on your own time. But basically, with this, it's asking us to use the data in the table to estimate w prime of 15. Let's highlight that puppy. W prime 15, or the derivative of w at 15. And this table here shows wt. That's what this little table is showing me already. right? And so basically with this, you're just estimating the derivative, right? And if I'm not mistaken, with derivative estimation, it's going to be like something similar to this. It's going to be f of b minus f of a over b minus a. And so if we're estimating 15, we notice that, again, 15 is in between 10 and 20. So we basically say the w prime, don't forget to write what it equals. Free floating work gets no credit. 15, that's approximately, or estimated, I guess. W20 minus 10 all over 20 minus 10, which is 90 minus 79 over 20 minus 10, which is going to give you negative 11. Oh, I apologize. I messed this up. This is the other way around. It's going to be negative 79 minus 90. Just because it's bigger, guys, doesn't mean it's going that way. That's how you got your negative. Negative 11 over 10, which is also the same thing as saying, like, negative 1.1. Yeah, that's close enough. And that's basically your rate of change at 15. And so I'm going to go ahead and just type this up at the bottom because I'm tired of writing. So this is basically saying the water in the bathtub at, what is 15? It's 15, at 15 minutes. At 15 minutes is, and because it's negative, we understand that it would be cooling because WT is Fahrenheit, is cooling at approximately negative 1.1, and it's a rate of change, so you have to have your units. Degrees, let's just put Fahrenheit in here. Fahrenheit per minute, because that is our rate of change. All right, cute. And that's what that last thing looks like interpreted. Anyways, that's all for 4.3. See you in a little bit for 4.4, which is this, but on steroids. Okay, bye.